You can think of UV and fragment coordinates as kind of a grid map of the texture. They start at 0, 0 in the top left of the texture and go all the way to 1, 1 in the bottom right corner. The y-axis can sometimes be flipped depending on the engine you're using, so be aware of that if you ever see your results turned upside down. These coordinates are normalized, which means they're based on a percentage of the texture rather than the actual pixel dimensions. So whether your texture is 100 pixels wide or 1,000 pixels wide, the UV will always work the same way and will always go from 0 to 1 on both axes. Now, when we combine these two variables with the texture function, what we're doing is sampling the pixel from the logo at the current fragment UV coordinates and reading that color. This gives us the pixel's original color, which will be a vector 4 variable. That's just a fancy way of saying that it's made up of 4 individual parts. R for red, G for green, B for blue, and A for alpha, which is the transparency. We'll use vector 4 for many colors, but sometimes we'll ignore the alpha transparency and just use a vector 3 instead. These vector formats are commonly referred to as the RGB color format, and they're used all over in video, graphics, and shaders.